Assalamu alaikum warahmatullahi wabarakatuh. It's good to have you once again. I remain Ahmad Jibril, numeracy grade 7, grade 8 teacher, manager, as we normally call it here. This is going to be a revision class as far as numeracy is concerned. Starting with grade 8, we have a combination of 5 things to include algebra, number numeration, arithmetic, geometry, and statistics. So here I would like to urge you to ensure you pay maximum attention to what we are going to be discussing, as this has to do with all we covered so far. So if you are missing any part of what we have done so far, this summary covers everything we have done so far. So similar, let's go. So we start with an example from algebra. Here on the screen we have expand x plus 2 times x plus 6. When you have an expression of this form, the way we solve this is to take the first variable of the first bracket multiplied by the whole content of the second bracket. After which, we take the second term of the first bracket, which is 2, multiplied by the whole content of the second bracket. What do we mean by this? This is how it looks like. X in the first bracket is multiplied by the whole of the second bracket. The second term on the first bracket, which is 2, is as well multiplied by the whole content of the second bracket, and that is what we have on our screen. Next action to perform is to expand the bracket. How do we go about this? We multiply the content of the bracket by what you have outside the bracket. That is x times x, which gives x squared. X times 5, 5x. 2 times x, 2x, and 2 times 5 gives 10. And see how it goes. See, x times x gives x squared, x times 5, 5x. In the second bracket, we have 2 multiplying x to give you 2x, 2 multiplying 5 to give 10x. Now when you observe the expression we have, x squared plus 5x plus 2x plus 10, the terms that are in same term, 2 same terms we have here is 5x and 2x. As x squared is in binomial, x squared is in quadratic form, and 10 is just a constant. So we have 5x and 2x that can be added. 5x plus 2x gives 7x. So next we have x squared plus 7x plus 10, and that gives the solution to the problem. Next we have simplified x plus 4 squared. This is binomial expansion. So you can simplify it as x plus 4 multiplying itself. That is what x plus 4 squared means. So the same way we go about the previous example solved is same way we treat that same way we treat this question we have. By multiplying the first term of the first bracket by the whole of the second bracket, multiplying the same bracket of the second term, the same second bracket by the second term of the first bracket, and we have the x multiplying x plus 4 multiplying x plus 4. Now next is to expand the bracket by multiplying the content of the bracket by what we have outside it. Let's see what we got. X times x gives x squared, x times 4, 4x. The second bracket we have 4 times x, which is 4x, and x 4 times 4 gives 16. Then from the expression we have x squared plus 4x plus 4x plus 16, the common terms we have there is 4x plus 4x. They are the terms we have x. X squared and 16 are not in x. X are in power of 1. So we add 4x plus 4x to give you 8x. And so we have x squared plus 8x plus 16. This simplifies the given question. Next we have is write 24m squared NQ as product of its prime factor. How do you go about this? You write your 24 m square MQ. 24 is the coefficient of m square NQ. So we continue dividing the 24 by the least factor. The least factor that can divide 24 into equal parts is 2. So we divide 24 m square NQ by 2. 25 divided by 2 gives 12. So m square NQ remain. We continue dividing the constant term, that is the coefficient, which is 12, until we have 1. So next is to divide 12 by 2. 12 by 2 gives 6. 6 is the coefficient. 6 can also be divided by 2, which is the least possible factor that can divide it into equal parts. So 6 divided by 2 leaves us with 3. So the question we have here is 3. This time around, 2 cannot divide 3 into equal parts. So what we do is to divide 3 by its least factor that can divide. Mind you, 3 is a prime number, which cannot be divided by any other number except 1 and itself. So we divide 3 by itself gives 1. So 1 multiplied by m square NQ gives us m square NQ. Remember, when you have 1 in this situation, you don't write it, because 1 times m square NQ remains m square NQ. So it's as same as not writing it. So m square NQ. Now our constant have been exhausted to 1. So we deal with m square now. What do we divide m square by? We divide m square by its least factor, which is m. M square divided by m, reduce m square to just m, and NQ follow. We continue dividing m until it's exhausted. So m can be divided by itself, which gives us 1. 1 multiplied by NQ, we have NQ. We have exhausted the m time. Now I left with just n. This time around we have NQ. NQ can be divided by its least factor, which is n. When you divide NQ by n, the NQ will be reduced by 1 and will be left with n squared. N squared can also be divided by n, and it will be reduced to just n. Then the only number or the only factor that can divide n is the n itself. So we have n divided by n, we have 1. So the prime factors, the factors we have by the left hand side of the table is 2, 2, 2, 3, m, n, n, which gives the product or the prime factor of the given number 24m square NQ. So we have it this way: 24m square NQ equals 2 times 2 times 2 times 3 times m times n times n times n times n, and that answers the given question. The next question we have here is on highest common factor. On the screen we have find the highest common factor of 72 and 108. So we do this same way we solved the previous question. We express it as product of its prime factor, 72. And we have 2 times 2 times 2 times 3 times 3. 108 gives 2 times 2 times 3 times 3 times 3. How do you go about this? Just same way we treated the previous question. You express it as product of its prime factor. You have this. So from here, our HCF can be obtained by comparing the common factors. On 72 we have 2, downward 2, 2, 2, 2, 2, 3, 3, 3, 3. So the middle numbers on 72 is 2, and the middle number for the 108 is 3. So they are not the same. So they have to be common. As you can see, comparing this, we have 2 times 2 times 3 times 3, and these are the common factors of 72 and 8. So next we multiply out. 2 times 2 gives 4, and 3 times 3 gives 9. So 4 times 9 leaves us with just 36. So the highest common factor of 72 and 108 is 36, and that answers the question. Next we have is LCM. Using the same question we just saw, find the LCM of 72 and 108. We have the same expression as we do when we're solving for HCF. The only difference here is that we express it as power of 2 and 3, and this is what we have. Now when you check on the factors of 72, we have 2 raised to the power 3 times 3 raised to the power 2, and that of 108 we have 2 raised to the power 2 times 3 raised to the power 3. So we will take the highest factors. The highest factor of 2 is 2 raised to the power 3, and the highest factor of 3 is 3 raised to the power 3. So 2 raised to the power 2 raised to the power 3 is 2 times 2 times 2, and 3 raised to the power 3 is 3 times 3 times 3. 2 times 2 times 2 gives 8, 3 times 3 times 3 gives 27. Multiplying these two out, 8 times 27 gives us 216. Next, we move into commercial mathematics.